Hello student, today we will do the remaining questions of exercise 5.1. So your first question is find the value of k so that the function f is continuous at the indicated point. Okay, so here it is given that the function is, we have done two of this type of question in the last video. Now we will do few more questions. So it is given that the function is continuous at the indicated point and your aim is to get the value of k. So your function is fx is equal to kx plus 1 if x less than equal to pi, and fx equal to cos x if x greater than pi at the point x equal to pi. Okay, so this is your question. So what is given here? It is given that fx is continuous at the point x equal to pi. Okay, so since fx is continuous at the point x equal to pi, therefore we can say that limit x tends to pi fx is equal to f of pi. Right? This is by the definition of continuity. And after this writing this limit x tends to pi fx equal to f of pi, we have seen here that pi takes different value for slightly greater than pi and slightly less than pi. So you have to separate the limit x tends to pi to right and the left hand limit. Okay, that's why I have written this line, limit x tends to pi plus 0 fx equal to limit x tends to pi minus 0 fx is equal to f of pi. Now let us substitute the corresponding values. So what is the corresponding value of fx for x greater than pi? You see, it is equal to cos x. So I have written here x tends to pi cos x. After this, pi minus 0, that means slightly less than 0. Then what is the value of fx? It's kx plus 1. So I have substituted x tends to pi kx plus 1. And what is f of pi? Equal to pi value. So equal to pi is defined by this first way. So it will be k pi plus 1. Okay. Now after this we'll do the simplification. So here cos of pi we can substitute. Right? It is exists, so you can substitute. So we have got cos of pi and this is equal to k pi plus 1. Again it is equal to k pi plus 1. So no need to write down twice. That's why I have written it one time. Now let us substitute the value of cos pi. What is the value of cos pi? Hope you remember, that is equal to minus 1. Okay, and this is k pi plus 1, keep it as it is. Then k pi is equal to, if I bring this, your aim is to get the value of k. So I bring this minus 1 plus 1 to left side, it become minus 2. So minus 2 is equal to k pi. Then what is the value of k? It is equal to minus 2 by pi. So this is the answer. Okay, so here our question number 28 is completed. Now we will go to question number 29. So you see your question. What is the question? The question is same, that is it is continuous at the indicated point and your aim is to get the value of k. So your fx is defined by kx plus 1 if x is less than equal to 5 and it is equal to thrice x minus 5 if x is greater than 5 and it is continuous at the point x equal to 5. Right? So here it is given it is continuous at the point x equal to 5. So what will give? Since f is continuous at the point x equal to 5, therefore limit x tends to 5 fx equal to f of 5. This is by the definition of continuity we have got. After this you see, as the function has two different value for slightly greater than 5 and slightly less than 5. That's why you have to separately write down right hand and the left hand limit. So we have got limit x tends to 5 plus 0 fx is equal to limit x tends to 5 minus 0 fx equal to f of 5. Okay. Now we are going to substitute the value of the function. So what is f of x value when x tends to 5 plus 0? It is defined by 3x plus 5. So I have substituted 3x minus 5. Sorry, 3x minus 5. Right? And for 5 minus 0, the function is defined by kx plus 1. So substitute it. And equal to 5 is also defined by the first way. So k into 5 plus 1. Okay? Now let us substitute the limit value because it is polynomial. We can substitute directly. So 3 into 5 minus 5, this is what? K into 5 plus 1. Again it is k into 5 plus 1. So I have written it once. Then 3 5s are 15 minus 5 equal to 10. So this is equal to 5k plus 1. So 5k is equal to 9. That means k is equal to 9 by 5. So this is the answer. That is the value of k for question number 29. Let us go to now question number 30. This question is, find the values of a and b such that the function defined by this way is continuous function. So in this question, similar with previous, but in the previous question, the function, you have to find out one unknown, but here in this case we have to get two unknowns. The function is defined by what? By 5 if x is less than equal to 2. It is defined by ax plus b if 2 less than x less than 10, and it is defined by 21 if x is greater than equal to 10. So now let us substitute on the number line the critical point, then and it is a continuous function given. So what I am doing, let us find out at what point this continuous is not given. So we have substituted our critical point on the number line, and let us decide what is the domain of the function. So first critical point is 2, and then we have 10. 2 and 10 substituted. This is x is defined for less than equal to 2. So less than equal to 2 means on this side. 2 to 10, so in between 2 and 10. Open interval, and greater than 10. That means on this side. So what is the domain of the function? The whole real number. That means it is a continuous function for the whole real number line. Then here you see we have to find out two unknowns, that is your a and b. So I'll try to form two equations. Okay. So since the given function is continuous, it is continuous for all real number. Okay. In particular, we can say it is continuous at the point x equal to 2 and at the point x equal to 10. So first I'll consider the limit, that is continuity at the point 2, and we'll try to form an equation. Then we will consider the continuity at the point 10, and we'll try to form another equation. Okay. So first you see I have written here that since continuous at the point x equal to 2, so limit value is equal to function value, and as we have seen here, for less than equal to 2 the function is defined by 5, for greater than 2 function is defined by ax plus b. So we have to do left hand and the right hand, right and the left hand limit separately. Okay. So I have written here. One step I skip here. If you want, you can write down that step, that is limit x tends to 2 fx equal to f2. That step, if you want, you can write. Then I have substituted the values of this is done. Then here substitute the values of fx. What is fx? It is ax plus b for greater than 2, and it is defined by 5 for less than 2, and equal to 2 also the function is defined by 5. So here also I have substituted 5. Then let us do the calculation for this limit. So it will be 2 plus 0, no need to write, that's why I cut here. So a into 2 plus b is equal to 5. This is also 5, so I have just written it once. So we have formed 2a plus b is equal to 5. That is one equation we have formed. Then another equation we will form from the continuity at the point x equal to 10. That's why I have written here, since f is continuous at the point x equal to 10. So I can write down what? Limit x tends to 10 fx equal to f of 10. Again you see in the question, and for greater than 10 and less than 10 function is defined in two different ways. That's why here I have separated right hand and left hand limit. So limit x tends to 10 plus 0 fx equal to limit x tends to 10 minus 0 fx, that is equal to f of 10. Substituting the corresponding value, greater than 10 it is 20, less than 10 it is ax plus b. You can put the bracket if you want. This is equal to 21. Okay, so limit value we can do, there is no place to substitute x, so it will remain as it is 21. This is what? A into 10 plus b, and this is 21. Keep it as it is, so as twice, no need to write. So we have found here that 10a plus b is equal to 21. This is another equation. You see, now your aim is to get the values of a and b, and if you compare equation 1 and 2, actually if I subtract, any method of solving you can use, any method of solving of linear equation in two variables can be used. So here I have used this method, that is what? Elimination. Because you see, b, if I subtract, b and b will be cancelled out. So what I have done here, from equation number 1, from left hand side I have subtracted equation number 2. From left we have subtracted left, and from right we have subtracted right. So your left side is what here? It is twice a plus b minus 10a minus b. Okay, this is your left hand side. And the right hand side is 5 minus 21. b and b will be cancelled out. So what is left? Minus 8a is equal to, here on the right side we have minus 16, and then a is equal to minus 16 by minus 8, which is equal to what? 2. After getting the value of a, we substitute these values of a either in 1 or in 2. I have substituted in 1. So it becomes 2 into 2 plus b equal to 5. That is here 4 plus b equal to 5, that is b equal to 1. So we have got the values of a and b. Value of a is equal to 2 and value of b is equal to 1. So here this question is completed. Okay, now let us go to the next question. This is the question. Let us read the question. show that the function defined by fx equal to cos of x square is a continuous function. You see, this is not a direct question. Okay, so let us try to get cos of x square by using the definition of composite function. So here you see it is a combination of the function. What is the function combined here? One is the square function and the other is cosine function. So I name the function as hx equal to cos x and another function gx equal to hx equal to x square and gx equal to cos x. Okay, it's up to you. We can give any name. Then after that, let us find out the composite function of this one. So I have find out here h of z of x. By definition of h of z of x, what is the value? H of zx. Substitute the value of zx. What is zx? It is cos x. So h of cos x. That is hx is x square. So what is h of cos x? It is cos x whole square, which is cos square x. So I have not got this your function. Then let us find out GOH. If you got here, suppose your required function, then no need to proceed this one. But as I have not obtained cos of x square, when you find out h of z, so I have to find out GOH of x. By definition, it will be z of hx. Z, what is hx? It's x square. So you see now z of, suppose it is y. If it is z of x, it is x cos of x. So z of y will be cos of y. That means z of x square will be equal to what? Cos of x square. And then you see GOH of x is equal to your fx. Now you see we have got our required function. And now we know one result, that is polynomial function is continuous because it is a polynomial function I have considered, and this is trigonometric function. Trigonometric function cos x is also continuous for all x belongs to R. Okay, and product or composite function is also continuous, so fx is continuous. So that will complete our result. Now let us proceed to one more question of this type. Show that the function defined by fx equal to modulus of cos x is a continuous function. Here you see, first to try to get modulus of cos x, because it is a combination of modulus function and trigonometric function. So I have named as the function as hx as cos x and zx as modulus of x. Now after that I have find out h of z of x. By definition, h of zx. Zx is equal to mod x. So modulus of x is h of modulus of x. That means you can consider this as y. So it gives you h of y. Suppose if you consider it as y. H of y will be equal to cos of y. That means here it is cos of y. Y is modulus of x, so cos of modulus of x. That means we have not got our function. That's why I have find out GOH of x. And by definition of GOH of x, it is z of hx. Z, you keep it as it is, put the value of hx, that is cos x. Now you think it as y, z of y. Z of x is modulus of x. So z of y will be modulus of y, that is modulus of here y. Y means cos x, so modulus of cos x. And which is your given function fx. So that means you see that your given function fx can be written as a composite function, that is GOH. And now you see, we know composite function is continuous. Composite of two continuous function is continuous. And already we know cosine function is continuous for all real number. Modulus function is also continuous for all real number. This we have proved. And composition of two continuous function is also continuous. Hence, this is continuous. That's the conclusion I have written here. Trigonometric function cos x is continuous in all for the all real number. So hx is continuous. Modulus function is continuous. And so gx is continuous. And composite of two continuous function is continuous. Hence, fx is continuous. So this completes the solution. Hope you understand how to do that composite function continuity. Okay, one more question of similar type. Let us complete now. Okay, so your question number 33 is examine sine of modulus of x is continuous function. You see, this is again similar with the previous question. It is a combination of trigonometric function and modulus of function. As earlier I have named here, suppose gx equal to modulus of x and hx equal to sine x. You can give your own name also. Okay. So let us find out h of z of x. It is equal to h of zx. H of zx. Zx value substitute, that is mod x. H of mod x. What is h of mod x? Sine of modulus of x, which is your fx. Since I have got our required function, suppose it is fx, so don't have to do GOH of x. Okay. So now write down the conclusion. What is the conclusion? You know that modulus function is continuous for all real number. Sine function is continuous, that is trigonometric function is continuous for all real number, and composition of two continuous function is continuous, right? That's the conclusion I have written here. We have modulus function is continuous for all real number. Trigonometric function sin x is continuous for all real number. Composite of two continuous function is continuous. So hx and gx continuous, and hence fx is continuous. Okay, in this way we have to do the solutions of composite function. Now one more important question is there, and this is the last question of your exercise. Find all point of discontinuity of the function defined by fx equal to modulus of x minus modulus of x plus 1. You see, it is a combination of difference of two modulus function. And you know modulus function defined by, for greater than the function it is defined in one way, for greater than equal to, and for less than it is defined in different way. We know that definition. So I have to break up these two for greater than and less than term in terms of inequality. Okay. So modulus of function, we know the definition, that is what? It is equal to x for x greater than 0. It is equal to 0 for x equal to 0, and it is equal to minus x for x less than 0. Similar way we can find out the definition of modulus of x plus 1. Rough work I have shown here. So modulus of x plus 1 is defined as it is if it is greater than x plus 1 is greater than 0. You put here a 0. Okay. And this is defined by 0 for x plus 1 equal to 0. And this is equal to minus of x plus 1 for x plus 1 less than 0. Okay. Now I don't require x plus 1 greater than 0 or less than 0. That is not required. We require x greater than 0 or less than 0. That is important. That's why I have written here x plus 1 is greater than. If I bring this or minus 1 from both sides, it becomes x greater than minus 1. Similarly, here 0 when x is equal to minus 1, and it is equal to minus x minus 1 if x less than minus 1. So if I break up these two, then we will get the detail, in detail this one. So here you see I have separated it. Now put it, your critical points are, what are the critical points? 0 and minus 1. So I have substituted 0, and on the left side of 0 we have minus 1. So you see this divides the whole number line into 1, 2, 3 parts, and equality also there. So I'll break up it. For one part I'll write down for less than minus 1. So for less than minus 1, let us see what is the modulus x value. Less than minus 1. You see, less than minus 1. Obviously less than minus 1 means less than 0, because it is known for you to for less than 0. So less than 0 it is defined by minus x. For less than minus 1 also it is defined by minus x. So modulus of x takes the value minus x. Minus sign you put. Now decide what is the value of this modulus of x plus 1. Modulus of x plus 1, it is for less than 1, and less than 1 modulus of x plus 1 is defined by minus of x plus 1. So this one minus of x plus 1. And this is done for x less than minus 1. Then I consider this point. That is what? Minus 1 and 0. Equality I have substituted later actually. Okay. So minus 1 and 0 in between this. In between this interval minus 1, for modulus value I have to check. It is, you see, when I consider this interval, then also x value is less than 0. So modulus x is equal to minus x. And here for this one, it is less than 0, but less than 0 does not mean that less than minus 1. You see, less than 0, but it is greater than minus 1. So the function value is equal to what? Greater than minus 1, it is x plus 1. So minus this minus sign I have substituted, and this value is equal to x plus 1. This is for minus 1 less than x less than 0. And for equal to minus 1 also, you see, the function is defined by 0. That means this remains as it is, so here it is equal to is included. But here you don't have to put this equal sign. Equal to 0, I'll consider in the next part. You see, because for equal to 0, the function is defined by x is equal to modulus of x equal to x for x greater than equal to 0. So greater than equal to 0 I have considered here. And greater than equal to 0 means it is positive. So here this value is positive. Minus sign you put. And here also this is greater than 0. So obviously it is more than minus 1. Greater than 0 is on the right side of minus 1. That means positive. So the value is equal to what? X plus 1. So you have considered this. Hope you understand these things. This is very important part. I have considered all this from here, this rough part. Okay, now I have done the simplification part. It is equal to what? Minus x minus minus plus x plus 1 for x less than minus 1. This is minus x minus 1. Okay, minus 1 less than equal to x less than 0. It is equal to x minus 1. Okay, for x greater than equal to 0. Now doing the calculation, what we'll have? It is equal to 1 for x less than minus 1. It is equal to minus twice x minus 1 for this interval. And this is equal to minus 1 for x greater than equal to 0. So I have written these things. This is written. Now you see your given question is simplified into this question. You have to find a point of discontinuity. This question is simplified into this form. Okay. Now you see your critical points are minus 1 and 1, and this one interval already you have seen in the number line. So you divide it into cases 1, 2, 3, 4, 5 case. one interval, second interval, third interval, and equality at 2 points. Okay, so I have considered the first case. For x, here I have again written the function just to see it easily. So for x less than -1, the function is defined by what? 1. So fx is equal to 1. And fx equal to 1 is a constant function. So being a constant function, f is continuous for x less than 1. Then I'll consider the point next interval -1 and 0. For -1 and 0, in between -1 and 0, case 2, the function is defined by minus twice x minus 1, which is a polynomial function. So being a polynomial function, f is continuous for all -1 less than x less than 1. Then I consider the next case is for greater than 0. So for greater than 0, function is defined by -1. It's again a constant function. So the function is continuous for x greater than 0. Now I'll consider the cases for equality, equal to -1 and equal to 0. So at x equal to 1, let us take the continuity. You see, for less than 1 equal to -1, for less than -1 and greater than -1, the function is defined in two different ways. That's why you have to do left hand limit and right hand limit separately. So x tends to -1 minus 0 fx. -1 minus 0 means less than -1. Less than -1, the function is defined by 1. So this is 1 and calculate the value is 1. For -1 plus 0, that is greater than 0, -1. For greater than -1, the function is defined by minus twice x minus 1. That is -2 into -1, that is equal to 1. So limit values are equal, so limit exists. Let us get the function value. F of -1 equal to -1. Equal to -1 is defined by this way. -2 into -1, that is 2 minus 1 is equal to 1. So limit value is equal to function value, hence function is continuous at the point x equal to 1. And after that, at the point x equal to 0, we have to check. So for 0 also, we have seen the function is defined in two different ways. So I have separated here right and the left hand limit. So right hand limit value substituted 0 plus 0. 0 plus 0 means greater than 0, it is defined by -1. And for less than 0, it is defined by -2x minus 1. Okay, so doing this calculation, this is -1, and here substituting 0, we got -1. That means left hand limit equal to right hand limit. And since left hand equal to right hand limit, therefore limit exists. And function value is also equal to what? Here you see equal to -1, the function is defined by, this is equal to what? Equal to 0, it is defined by -1. So this is -1. Function value equal to limit value. That's why limit is continuous at the point x equal to 0. So here we have seen the function is continuous for all numbers. That means there is no point of discontinuity. So here your continuity exercise is completed. Okay, listen the video properly, and after that you write down your solutions of the questions. Thank you.